Hello everyone, welcome to our new video about chemistry with Dr. Andrew Szydlo. I think he will come soon.
Hello.
Hello,
Very, very good morning to you, dear Ferdinand.
good morning
Um,
to you too.
Ferdinand, that's right. Sorry, let me just put my picture larger. There we are. Let me just finish my.
Enjoy your meal.
Thank you very much. Um, good afternoon to you.
Yes, thank you so much. And how is it going? How is your life?
The line is excellent. I can see you. It's even better than last time, I think. Maybe I pushed a better button this time.
It's good.
Excuse me, I've just finished a little muesli for breakfast.
Enjoy your meal again.
I have been up for 2 hours, of course, 3 hours, in fact. So,
Yes, of course.
so tell me, what would you like to talk about today, dear Ferhat? What would you like to ask me about?
Dr. Andrew Szydlo, first of all, I would like to thank you again for accepting my another video.
That is my greatest pleasure.
Chemistry, and also after our first meeting, and I watched all of the videos, all of your videos about chemistry on YouTube.
Oh my
And
goodness.
also, I took some notes to show my students and my audience, and. Maybe we can talk about sulfur or magical mercury or pyrotechnic mixture. If you want, you can talk another.
Well, I think perhaps a good topic always with chemistry is pyrotechnics, because
Yeah.
there's no doubt that fire is one of the most important or one of the most dramatic chemical processes known. It's one of the most dramatic chemical reactions since the history of the dawn of man, of course. And our ability to use fire and to understand how fire is made or how fire burns is one of the great achievements of the chemical sciences. And I think when one gives lectures or one talks about for children about explaining the science of fire, this is a very, very important to explain it correctly. But I think let's talk about doing demonstrations. So any chemical lecture or presentation which I give, I always try and involve fire somewhere. Excuse me. This will be in the context of either a spot, and it has to be spectacular. Fire. I always have a candle burning. I don't know whether you've noticed, but for many of the talks which I give, the public talk lectures, I always have a candle burning. This is perhaps following on from the great Michael Faraday, who used to give talks for children, and he devised a very, very important series of lectures called On the Chemical History of the Candle. And he used the candle flame to build the entire framework of chemistry from it, from the combustion of the hydrocarbons which are present in wax to the products carbon dioxide and water. Must excuse me, I'm going to get a glass of water.
No problem.
I think I've got a little bit of water here. So I'll just get a glass of water. And from Michael Faraday's analysis of the candle, it's a book. His lectures on the history of they have been published as a book, and they've been continuously in print for a very long period of time. He used the candle and the flame to explain, as I said, the carbon dioxide, water vapor, the concept of an element, the concept of a gas. He built the whole structure of chemistry and analyzing how do you test for carbon dioxide, oxygen, air, what is air made of, what are hydrocarbons made of, the way that the wax flows up the wick. All of these issues, you see, stem from fire. So that I would warmly recommend, if you haven't already seen that book. I wrote a paper called Michael Faraday, the Educator. And in that paper, I went into his methodology of teaching, which was of which the lectures on the fire were a particular, on the candle, played a particularly important role. Now, if one gives a presentation for children anywhere, as I said, what sort of flames do you use? Indeed, for any presentation for children, I think there is chemistry must be associated with color changes, with some sort of fire, some sort of smoke, some sort of explosion, something which that's what everyone associates chemistry with. The science of substances turning into different substances, but this can manifest itself in many different ways, you see. So I have this lecture which I give for all children, which is called The Magic of Chemistry, something like that. And I have given this talk now about 800 times. And I am now giving it to even children aged 5 years old, but in a different way to the way I present it for older students. And of course, much shorter. For the 5-year-old children, half an hour is enough. And as I said, different ways of making fire. So you can show something very simple like a candle burning, which isn't very exciting, but then you can make a spontaneous combustion from potassium permanganate and glycerine, which is again, a very, very important. When presenting this particular one, you have to be careful with the smoke which is produced, because it makes a bit of smoke and children will cough and, etc. But if you have good ventilation, there is no problem at all, and with small amounts. Another experiment which I demonstrate on an occasional basis is the chemical volcano, ammonium dichromate. Once again, the experiment is very beautiful, and I can tell you from the experience with children, they are always amazed by this. But once again, we have to be, especially since the products of combustion are water vapor and nitrogen. But you have the dust of chromic oxide which goes into the atmosphere. So if you are in a situation where you can't allow this for some reason, then the experiment can be done in a closed container, but with a wire mesh to prevent, etc., etc. But in a large open space, I frequently give talks in schools where there is a large open space, and again, I demonstrate it occasionally. The problem with that experiment is tidying it up afterwards, because you have to sweep up but when I do that, when I do sweep up the the chromic oxide afterwards, I always explain the importance of being tidy. And then I use that particular demonstration, which is spectacular, but I always explain, and indeed in all teaching, it is so important to stress the importance of being tidy. And I say, if you are tidy, you are showing respect for yourself, because you yourself know what you are doing. You have a tidy bedroom and you are organized, but you are showing respect for the environment, the place where you are, and you are showing respect for other people. And I make a great thing out of this for children. And I always say to them, I always congratulate them on how tidy they look, you see. And I say, I know why you are so tidy, because you have a tidy bedroom at home. And then everyone starts laughing, because of course they don't necessarily have a tidy. Right. So I say, you must try to be tidy. That's the important thing.
Because chromium trioxide is highly toxic compound, and also it elevates everywhere and stuff like that. Therefore, we have
exactly. When I do the experiment with chromic oxide, which isn't it's not that toxic. I always have a shower afterwards in case I have some in my hair.
Yes. I have a question, Mr. I have a question for you. And also, I wonder, normally, if we have a spill of mercury, for example,
yes,
normally we are using the zinc or sulfur powder is used to eliminate. And
correct.
do you have any other idea, or do you have any background information about this situation? Do you have
Yeah, well,
any?
I'm currently preparing a paper, as I told you, on mercury, and it's called Magical Mercury, and I've
I
been
wonder your paper. I wonder your article about that.
yeah, well, I'm going to, as I say, it's a lot of work, and I've got a lot of ideas, and I've actually been showing experiments in my own school with mercury. The thing is, if you have, mercury spills are very rare. You have to do experiments with it in a tray to contain any. But if you do get a mercury spill, then, as you said, either zinc or sulfur powder, and you just wipe it out. The important thing is to recognize that a mercury vapor is highly toxic. I have set up an experiment in my school, which I will be publishing the results of, and you will read about this. That mercury vapor it will actually form an amalgam with gold. So I have a little bottle, and in the bottle I have put a piece of zinc foil, a gold foil. I will show you a photograph, and I took some photographs of this bottle with zinc with gold foil in it, and there you have a, let's say, there you have a picture. So this is I hope you could see that. That's a bottle, and there is the gold, and there is the mercury. And I'm going to leave this for 6 weeks because, according to the experiment, the vapor pressure of mercury is sufficient that after 6 weeks, this gold will turn silver. So I will tell you the results of that experiment. But I think, as long as this is the general principle, if you are a scientist or a chemist demonstrating any kind of experiment or doing any kind of experiment yourself, the most important thing is for you to have tried it yourself and to recognize all the limitations, or you must read about it to make sure, and historically, what potentially could be hazardous with the material. So mercury is renowned for the fact that if you're breathing mercury vapor, let's say that's been spilled in a laboratory over a long period of time, then this is a potential health hazard because mercury vapor affects the brain and so forth. So, for instance, in our school laboratory or prep rooms, when the mercury vapor everyone started talking about 40 years ago, that people used to come around and carry out an inspection for mercury vapor in the atmosphere. Because if sometimes you had a broken thermometer, mercury were in between the floorboards, then small drops of mercury would release mercury vapor. And of course, they never find any because the amounts that you get from is nothing. But if you have a larger mercury spill, then you don't want to have. Then you use sulfur and you sweep it up. But the honest truth is, if you take care, the most important thing, prevention is better than cure. So you don't want avoid the spill in the first place. That's the important thing, you see. So as I said, I'm preparing a whole load of work. I'm reading about mercury in history, mercury in medicine, and I've actually sketched out a whole load of subsections which I'll be writing about. Mercury in medicine. I'm going to be entitling that section The Mercury Delusion, because today we know that there are no compounds of mercury which are beneficial for health. So the question which arises is, where and why did people use mercury as a medicine, or did it must have done some good. So I will be looking to see historically in what situation were mercury compounds useful? How did they help people? They must have done somewhere. They can't all have killed everyone.
So and also, I think the most important part of your articles are the historical background.
Yes.
Giving the reactions and the stuff like that. This is a highly important situation. First of all, we have to learn the historical part of that element, compound, it doesn't matter, and then the reactions.
Yes, well, this is exactly what I've always wanted to stress. You see, this is what's disappeared from the chemistry teaching today. Is
Yes.
where has this come from? It's not only chemistry; it's biology, physics. The three main sciences which are taught in schools is the. I can't comment on biology or physics because I don't teach it. But I think also the historical context has, to a large extent, or completely disappeared. In chemistry, nothing. No one knows anything today who has even a degree in chemistry. They will know nothing about the origins of how it came about. So this is again of paramount importance. And as you know, in all the articles I write and all my lectures and teaching for children, I have always stressed where it has come from, because that's the way I was taught. I was taught at school, and I wasn't examined on this, but it enabled me to appreciate the cultural background of knowledge. And of course, chemistry is universal for the human race, everyone in the whole world.
And also another important situation is when I look at the channels about chemistry on YouTube, and also there are lots of different channels about the chemistry, and also
Yes.
some of them are not the people producing the different experiments, and also they are not chemists, but they are saying I am a chemist. But when I look at their background, there is no any chemistry education and stuff like that. This is another handicap about this situation.
Yes, yes, yeah, I know. People who don't know who pretend they know and they don't
Yes.
know. Maybe I don't watch that many. I do follow. I do occasionally
Evet.
see. There is a colleague of mine told me yesterday there is a good YouTube man called Chem Historian. He does chemical history,
Hmm.
especially. I think it's called Chem Historian because he sent me a link to a video, because we're trying to find out whether in ancient China they had rivers of mercury for one
Yeah.
of the emperors. But I don't think it's been proven. So, but then this man called Chem Historian, apparently, he apparently is very good. But you may have come across all
Yeah,
the.
normally I have a sorry.
There are so many
Yeah.
videos. I don't have the time. It's too much,
Because of your showing experiments and stuff like that. Your
I'm doing that all the time, you see. I'm doing experiments all the time. So
yeah.
please ask another question.
No, if I disrupt you, Mr. Szydlo, I'm so sorry because you're an idol for me. Therefore, I want to make another meeting
Yes,
with you.
one of the important experiments I show with fire, because I'd like to go back to fire and explosion, is the
Yeah.
way that petrol burns in a motor car engine. And that is an experiment where I explain the principles of understanding combustion. And you may have seen this old thing where I have a tin can and it explodes and the lid goes shooting off. Have you seen this on one of my demonstrations? I show it to all the children. And you explain how petrol burns in a motor car engine. And that if you have not, I recommend this. I think the Royal Institution have actually cut out the bit where I have done this, as I made a little 5-minute mini video where I explain how a motor car engine works. And for this, you need some petrol, and you have to explain how petrol burns without just in the open air, and then show a candle burning, which is wax, and a wooden split. They all have a yellow flame. And then you show that the yellow flame produces soot by using a white porcelain dish, and you say that this is incomplete combustion because the soot is left over and it has come from the chemical composition of the wood or the hydrocarbons. Now, if you cannot use, because in some places people are scared of using petrol, you could use octane or hexane, cyclohexane, which are, permitted chemicals. But the honest truth is there's no problem at all with petrol. The amounts you have ever are very small. 10 centimeters cubed is all you need to have in a bottle. So it's nothing which presents any major hazard. And of course, you have to be careful if you're doing the experiment and using petrol or even cyclohexane in a small bottle like this, you don't accidentally knock it over. I once did. I've done this experiment 800 times, and once And so what you have to do, I knocked it over with my hand, and I had some petrol, which was on the floor, etc. And I just simply said, look, I've just knocked over the petrol. This is potentially very hazardous. I blew out the candle flame, and I just wiped everything up with some paper tissues and towel, and I put it in a plastic bag, and I tied the knot so that the vapor couldn't get out. And then I make use. So sometimes if something goes wrong, you never ever try and pretend that it's everything. You say, look, something's gone wrong. And sometimes an experiment doesn't work. And if an experiment doesn't work, then you say, look, this doesn't work because, and you say, and you know what, I always then have 2 or 3 attempts and I always get it to work. So I think it's very important when you do science presentations for anyone is to be honest and say, look, science is not easy. And if something doesn't work, then you say, look, everything that we have is the result of thousands of failures. Not everyone works every time. You know, every experiment we do has been developed through the ages. And if we can do it successfully today, that's because somewhere people have not done it successfully. So that's very important. As I say, I'm very fortunate. I very, very seldom have any kind of mishaps. I've certainly never had any accidents or anything. Another very important thing when you give talks is to have a risk assessment, right? So I always write a detailed risk assessment, and I also have, because depending on what school you're doing, because as I say, I travel around a lot, so you have a detailed risk assessment and a method statement. Now, the people who will be reading these, they won't actually know the chemistry, because the people who usually read them are administrators in schools, and they just want to know that you are familiar with all the risks. And I always say that I'm happy if anyone has any questions or etc. Very happy. I've never ever had a single problem with risk assessments. Occasionally at universities, where the people in charge are very knowledgeable, they have asked me to highlight a few things or to explain in more detail. Never a problem. And people doing these risk assessments is very time consuming, but you do it for the children. I don't do the risk assessment for myself. I do it for the children, because if you want the children or the students to see the experiment, well, you have to be prepared to overcome the administrative obstacles. And I think it's very good, because when I do the risk assessments, and especially if I'm doing it for experiments which are for a new program or for sometimes for children, it makes me think things through myself better. So it's a very good way of formalizing a presentation. So going back to, so for petrol, again, the experiment with the tin can exploding, if you haven't seen it, you find that very good. It's a very straightforward, very simple to do, and it's always spectacular for children, because it demonstrates the principle of complete combustion and incomplete combustion. Yeah. So incomplete combustion is the yellow flame. Complete combustion is a blue flame. And they see it, and as the lid goes shooting off with a bang, and it's surprising. Every time I do that, it's the best experiment. Everyone claps and they all say, this is amazing. And then I tell them, why is this? And I say, because, and this is one of the most important things I always say to children, because 250 years ago, chemists made one of the greatest discoveries of science of all time. And I say, this is very easy. Air is a mixture. I say this, it's a discovery. Air is a mixture. And then I explain to them why this is such a great discovery. But I say to them, first of all, you look around and air doesn't look like a mixture, does it? You know, you can't see, look, here's oxygen, here's nitrogen. They look the same. And so I showed them a jar, 2 jars, one with colored beads and one with white beads. And I said, you can easily see which is a mixture, because you can see them, but in air you can't see. And then you have to recognize the fact that for children, the concept of a gas is not an easy one. We know it's a gas, right? But when you're talking to children aged 7, 8, 9, 10, and you say it's a mixture of two gases, that's very, very difficult to and you say, well, and I say, here's some oxygen. You can show a jar of oxygen and a jar of nitrogen and say these are quite different, but they look the same. The terminology which was used before the word gas was different kinds of air. And that's quite, you can understand that better than the concept of a gas. So in the olden language, the language of the alchemists, or the language of the before modern chemistry, people used to talk of different kinds of air. So for instance, the gas hydrogen, if you look up hydrogen in who discovered hydrogen, it says Henry Cavendish discovered hydrogen in 1766. Now that's not true, you see, because hydrogen had actually been known in the medieval times. Hydrogen had been known in 1400, 1500. But they made it by reacting iron with sulfuric acid. And they called it flammable gas, flammable air. They called it flammable, smelly air. It was air which burnt. And so it was actually known and identified as a substance. But what Henry Cavendish did, which was his great achievement, he characterized hydrogen. So he said, hydrogen is a gas. It's an element. It has a specific gravity of 0.089 grams per liter. It burns with a flame to make oxygen. So the correct way of describing Henry Cavendish's discovery of hydrogen is to say he was the first person to characterize hydrogen. That's the word which I now use, and which I think is more accurate, because hydrogen had been known, but it had not been recognized. And that goes for many of the other gases as well. But the concept of a gas for children is very, very difficult. And so I could say the gases are called I said the gases in air are nitrogen and oxygen. But you could say the gases in air are A and B. The gases in air are 1 and 2. You don't have, the words nitrogen and oxygen convey a whole lot of ideas, which we know. Oxys from acid maker, nitrogen, I don't know, but there is a word. So, but it doesn't really matter for the children, as long as you tell them this was a very difficult idea. And I use the 5 fingers of one hand, and I say nitrogen, 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 oxygen. And I say that in a simple way is the way that air is made up. And one child recently, a 7-year-old, said, "What about carbon dioxide?" I said, "I'm terribly sorry, you're right." I said, there is a tiny amount of, and I always have to then say, you have to say that 1% of the air is made up of other gases. Sometimes children will have heard of other gases, you see, and they will ask you, and you have to be careful not to be caught out, you see. So, but roughly 5 fingers and 1 finger, 5 of nitrogen and 1 of oxygen. And then you explain that oxygen is the gas which is necessary for burning and for breathing. And then, of course, I always do a very simple demonstration because I'm focusing on fire and explosions, right? I always do a simple demonstration in which I make some oxygen gas from hydrogen peroxide and potassium permanganate. I have a 1 liter beaker. It's very, very, very easy to do. And if it's possible, to make the room darker. And then you just relight the glowing splint, and that is always beautiful for children. And do you know, I once had a very intelligent question again for a young child. You put the splint in and it relights, you see. But sometimes the splint relights and it makes a little pop. It goes pop. And the child said, "Sir, but surely hydrogen goes pop." And I said, you're absolutely right. And you know why it relights with a pop? Because there is indeed hydrogen. It's produced from the pyrolysis of wood during the pyrolysis of wood, which is what's the product that you're... But that was an amazing observation made by a child, that it wasn't just relighting, but it was relighting with a little pop. Now, that doesn't always happen, but the child did notice that. So once again, you have to have a huge body of knowledge and always tell the truth. And you always say, this has happened. I don't know. Sometimes you don't know the answer. There's no reason why we should know everything.
It's a good observation, yeah.
Yeah. And then you see, I do this experiment. I use this way of making oxygen. To make something burn better. And what I do is I burn alcohol. And I have an experiment which I invented myself about 30 years ago, in which I have an evaporating basin, and which I add alcohol and hydrogen peroxide, and they make a series of banging sounds. Do you know what? Maybe next time, have you seen? I could show you these experiments in my kitchen here. Would you like me to, next time we meet? Would you like me to show you some of these experiments?
Yeah, why not? And also, if we make another meeting with you, and if you have any time, we can make some experiments. Yeah.
Yes. Do you know what? Because next, I'm telling you this. I'll tell you why. Because next week, on August the 12th, Professor Ramasamy from the University of Mauritius is organizing a World Youth Day in commemoration of let me just tell you, it's one of the great chemists, Schrödinger, wave mechanics, right? And I am going to be giving a live presentation here at 7 o'clock London time. That will be 9 a.m. your time, which will be screened for the whole world. And you will have access to this. And it will be a half-hour lecture on chemistry for young people. So I will send you the link for this. And do you know what? I will show you these experiments I've been talking. I could do them here. And did you know I gave a talk to students from Boğaziçi in front of this television a few years ago.
You made a lot of experiments. Yeah, I watched that.
Yeah. Well, I think I will do that again. But I will write to you an email, because the professor wrote to me and he asked me whether I could do something. And I said I could, but I hasn't yet confirmed. But if that happens, then I will definitely, it'll be a half hour. It's a half hour, and I will send you the details. And you can also, and it's a whole day conference. I'll send you detail, but there's also another program of mine which you'll have access to. So I'll tell you about that as well. That's all happening, I think, next week. So, but let's go back. So with the oxygen and the idea of gases and making things burn is, of course, difficult to understand. And if you explain, the way, everything in detail, from first principles. So air is a mixture. What is it a mixture of? Why was it such an important discovery? Because it enabled us to burn things more efficiently. And today, all hydrocarbon fuels which are burned, we have motor cars, we have central heating systems, jet engines, everywhere, makes use of the idea that air is a mixture. So in the olden days, in the sort of days of, they say, oh, oxygen was discovered. Well, actually, before they discovered oxygen, they had to know that air is a mixture. And that was a great error in teaching of the gases, because to say that oxygen was discovered doesn't mean anything. You could say that Maria Curie discovered radium. Now that, because she knew what she was doing, she was analyzing the radioactivity of the ores, and she was hunting for something. She knew what she was looking for, because there was this intense radioactivity which got more and more intense, and she discovered. That's correct to say she discovered, but to say that someone discovered oxygen or discovered hydrogen is a does not give you the true picture, because these are things which evolved over. Before you could discover oxygen or hydrogen, you had to know what a gas is. You had to know what an element is. There was a whole body of knowledge. And that's why I have developed this way of teaching, which I don't think anyone else in the world does, but you will now do it.
Yes, Mr. Szydlo. And also, again, I'm so sorry, we have the 7 minutes, last 7 minutes, because of the Zoom, you know that, for the minutes only. And also, as you mentioned, maybe after 3 or 4 months later, we can make an experiment or in the...
I will be very happy. I will be very happy. We could meet, I could do experiments here, certainly, and I can maybe even organize one where I can do it in the school laboratory.
Yeah.
But I have to use my phone. Could we do something? Would it work with a phone? Would I be able to have this switched on and we could do a Zoom with me filming? There is a possibility we could do something there as well.
If you want, we can make experiments, another for 3 or 4 months later.
Yeah, it would be a great pleasure. By coincidence, I'm now getting teachers from around England coming to visit me in my own school. Yeah. So yesterday I had two teachers and 2 students. I was showing them these experiments that I've just been mentioning.
Yeah, and also, Mr. Szydlo, I hope I can have a special opportunity to meet with you face to face in England.
I'm sure we will. I love traveling, and I have not been to Istanbul. It'll be the greatest privilege to fly out and to meet you and to meet some students as well.
If you want to come to Turkey, it was honor for me.
It'll be for me as well. I've got to learn some Turkish, though. That's my great challenge, to learn at least a few sensible words. Now, but listen, what would you like to ask? A couple of more questions, maybe something else?
And also, you explain all of the information about pyrotechnics, fire, and oxygen and hydrogen. It was highly good. And also, thank you again for accepting my meeting.
It's a great pleasure.
If I make any mistake, sometime I can write very fast. Therefore, I'm making special mistakes.
You must never worry at all.
Thank you very much.
Okay, so do you want me just to talk for another minute or 2, or should we just finish now, do you think?
If you want, you can explain something, but if you want, we can finish.
Okay. Well, one of the demonstrations which I do, which is not easy to do for children, and that's the history of gunpowder.
Yes, I love the gunpowder, and also I'm making some special potassium chlorate, sulfur mixture, gunpowder mixture, and stuff like that.
You have to be very careful with potassium chlorate and sulfur, because that's very dangerous. You know that.
Yeah, I know that, but I love so much. Maybe we can produce, I produced the elemental bromine with my students and stuff like that. I made all of these experiments in the special.
Have you actually made liquid bromine? Have you made bromine?
Yeah.
How is that with sulfuric and potassium bromide? And then
potassium bromide and TCCA, trichloroisocyanuric acid, and hydrochloric acid. Combination produces the chlorine. Yeah, and then
that's amazing.
Yeah.
That's
elemental bromine.
Okay. Listen, it's an absolute delight to chat today. I will email you with details if I'm doing this thing next week, okay?
Okay, thank you so much.
From Mauritius, you'll receive something, okay? Listen, we'll be in touch and we'll do something with some experiments.
Okay, thank you so much. And after that, we can make again special meeting only with experiments.
And I will come and visit you and meet your students.
Thank you so much.
Thank you very much. I bow humbly, and we look forward to being in touch again.
Okay. See you later.
Bye then. See you again soon. Bye. I'll look to switch off somewhere.
Yeah.
I think that's it. Bye then.
Bye.